Hello everybody, this is Udit Chaudhary and I'm presenting my Capstone Data 606 project analyzing NHA NES survey data. This is phase 3 of the Capstone project and I've built some prediction models, some machine learning models to uh, predict some of the classes in my data. So the first prediction model I built was to predict the level of cholesterol in people depending on how they answer their questionnaire. So I took the questionnaire data from the survey and the laboratory data and tried to predict the levels of cholesterol depending on how people answer their questionnaire. So from a first model, which is a random forest, I got a 0.74 R square score. And as you can see, here are the details of the random forest regressor I used to predict the cholesterol. I used 101 for trees in the random forest, and criteria was MSC. And I did not set any max depth or max features limit. So, and random state was set to none, and it was yeah. So it gave me a RF score of 0.74, which is not that good, but it's kind of decent. So we can work more on it. I also tried to predict protein and other some other classes. But and here's the predictor versus actual values for cholesterol. So the first values you see are the predictor ones, and the next ones are the actual values. The model they're actually pretty good for some of the records. For example, here like a predictor 191 as opposed to 199, and here like 105 or 113, which is like pretty good because it showed us a low cholesterol level and it was indeed quite low. So yeah, the next model was for prediction of protein content in the person. It had a better score for of 0.80, and I used the same random forest regressor for this thing and just changed the target class. This worked even better actually because it gave us a 0.80 R square score. And now I try to predict some of the diseases. There were in the laboratory data as such as presence of the hepatitis antigen. So basically, I'm trying to just predict if the person has gone to the disease based on his answering pattern of the questionnaire. The first model was a random forest classifier and gave an accuracy of like a test score of 0.85. The next one was hepatitis A, but it was MLP classifier, which is a multi-layer perceptron, which is a neural network. After that, I tried hepatitis B with a random forest and Gaussian in B, and the scores are pretty good actually. So like hepatitis B gave us a test score of 0.93, so it actually predicted pretty well that if the person has had hepatitis B in the past. Um, the Gaussian NB worked pretty well, but and it's not overfitted. As you can see, the training score for the running forest was 1, which is quite overfit. So I'm not sure how much trustworthy this model is. But for the Gaussian NB, the train score was 0.89, which is not that good, but not that bad. So it's not overfit. That's what I'm saying. This is the confusion matrix for hepatitis B MLP classifier. So it predicted 484 uh, positive, which are like true positive. So this is our precision, accuracy, and precision. 86 is a recall, which were predicted negative and were truly negative. These are the models for hepatitis B MLP classifier and hepatitis D random forest. These also had like pretty good uh, results. The MLP classifier in specific was pretty good actually because it had. So the MLP classifier was pretty good, and it wasn't overfit because it had some errors in the training data. The hepatitis D Panovirus, again, it's overfit as you can see because it gives a training score of 1, and but the test score was pretty good, like 0.98, but it might be overfit. We don't know. The last two models are for hepatitis D. One is a Gaussian NB and the other is MLP classifier. The Gaussian NB did not perform so well for hepatitis D. It had like pretty low training scores and test scores, but on the plus side, it wasn't overfit. The MLP classifier was overfit, I think, because it gave us training score of 1, which is kind of unbelievable. The test score for MLP class 497, which is pretty good, but given how many the segregation of classes and how the data is distributed among the classes, I think it's not that big a deal. Anyways, that was it for this deliverable. Um, I'm gonna keep working on these models and try to come up with better accuracy without overfitting the model. And I will try to experiment on other diseases other than hepatitis. Um, yeah, I think that's it for this video. Thanks a lot.